The Engineering and Technology Club at Fullerton College is involved in various projects. One of these projects involves the development of a NAT car. Members of the club will be competing at UC Davis using the NAT car that they've built.
A NAT car is actually quite a simple project to make. You need a camera to see, a servo to steer, and a motor to go. But why is it so complicated? Because you want to make it the best, you want to make it the fastest, and you're limited.
The camera functions sort of like a scanner, like you would have at home. It reads in things one line at a time at a certain size, and we take that information and we use it to figure out where it is in position to align.
90% of the workforce is based off of projects. If you can't get a project done in a certain timeline, you fail. You get fired. Things don't work properly. To have that already under your belt, going into the workforce and knowing that, it sets you apart from the others.
People treat computers like they're this great mystical thing, like it's magic on the inside, when it's really not all that complicated when you get down to like the bare bones of it.
The club is also involved in rescue robotics. They are developing a quadcopter that has the potential to be used in emergency situations. There is also a competition for these robots.
This is our quadcopter for our rescue robotics competition.
The whole basis of it is that in a disaster situation like a hurricane or a flood or something, you can't have somebody just cover an entire area and just walk around and look for survivors. So if you had a drone, it'd be great to send the drone over, or scans in a certain search pattern until it finds someone, it takes a picture of them, it takes the GPS coordinates and it sends it to a home base. That way search and rescue can go directly to the person. So most of it is 3D printed.
It does give you the opportunity to actually feel like you're doing something with what you're learning, which is kind of fun.
I've gone through programming C++ classes, math classes, and we've made projects, we made little things in class, but we've never actually done something with them.
The basis of the competition is that there's like a 100 feet by 100 feet field, and they put out these orange buckets everywhere, and those are the survivors. And so our quadcopter goes out, it finds each of them, it takes a picture, and sends the coordinates back.
They give students an opportunity to work together. And that's really huge, especially in the engineering field. Rescue robotics particularly, we have several different majors. You're not just working with one background, you're working with multiple people to get something complicated completed.
It also allows us to find a solution to a real-world problem. This kind of system doesn't actually exist yet. We're doing research like any other large university would. This is how things get fixed in the real world.
The future is bright for the Engineering and Technology Club. If you're interested in supporting the club, consider attending one of their meetings next semester.